Hey Alexis, it's me again. Um, Coterminal angles. What are they? I don't know. Alright, let's see. Coterminal angles, it's like a complete rotation of a ray. I think it's better if I just draw it. So if you have your quadrant and you have maybe this is 60 degrees. If this 60 degrees goes around in complete revolution and then stop back here. So it went around 300 because a complete revolution is 360 degrees. So if it goes around 360 degrees plus the original 60 degrees, it'll be 420 degrees. Now it's said that 60 degrees and 420 degrees are coterminal angles, which means that they are equal. So, and you could keep going around in circles and circles. So every complete circle, you just add 360. So when you go around one more circle and you add 360 to this, you get 087. So it'll be 780 degrees. So 60, 420, 780, they're all the same angle. So they just keep going around in circles. And there's a formula that you use, I guess, to know how many circles. So you just go with, the formula is theta, which represents whatever angle you're dealing with, plus n. N represents the amount of rotation you're going, times 360, which makes sense because 360 is with the value for a full rotation. So, I mean, that's pretty much all there is to us with unit circles. If they, I mean, not unit circle, coterminal angles. If they give you a value like maybe minus 75, and let's say find an angle that's coterminal to that, it's easy. So you just using this formula, you have your theta, so that would be minus 75. So you have minus 75 plus, so you have your n. Your n could be any integer. It really doesn't matter. And by integer, I mean a whole number, no decimals, no fractions, nothing. So you could put any value for your n. You could put 1, 2, 3, 4, 5, and you could put minus 1, minus 2, minus 3, minus 4, minus 5. It really doesn't matter. So let's put 1 because it's always easier to work with 1. So you go 1 times 360. So this becomes minus 75 plus 360, and that will give us 285. So with this, 285 and minus 75 are the same angles. And you could change this to 2, and this becomes 2 times 360. That would be 720, and minus 75 plus 720, you get a value, and that's still correct. So you could get a million coterminal angles. It really doesn't matter. And you could get a positive coterminal angles. You could get negative coterminal angles. So if the question specifically asks, like, give me a negative coterminal angle to this, so we dealing with minus 75. So you have minus 75 plus. So if they were specifically asking for a negative value, you'll put a negative value for your n. So your n becomes, it could be minus 1, minus 2, minus 3, doesn't matter. So we'll just go with minus 1. So that'll be minus 1 and then times 360. So this becomes minus 75 minus 360. And when you compute this, you should get 534 minus. So it'd be minus 435. So minus 435 degrees and minus 75 degrees are the same angle. So you could just keep going forward and backward. It really doesn't matter. And if you have a question like 908, and let's say find a value that's coterminal, find the smallest possible value that's coterminal to this. So for the smallest value to be that's coterminal to this, that means that the value has to be, it has to be an angle that's less than 360. So you have 908 plus, so we'll go minus 2 times 360. So this would be 908. So minus 2 times 360 is minus 720. So that's minus 720. So 908 minus 720 is 188. And 188 is less than 360. So 188 is coterminal to this. If they don't specify either positive or negative or smallest, then you could just put any value you want here for your n, and that will be the answer. So remember, the formula is theta plus n times 360, and n has to be an integer. So that's pretty much all I have for coterminal angles. Like I said earlier, if you have any specific questions, get in touch with Shar and she will give me that information and we could go from there. Alright? Bye.